In this video, we're going to graph a hyperbola. And so this is one of the conic sections that you can get when you have a plane intersecting a cone. And so this is the equation of a hyperbola. It's pretty easy to recognize because of this minus sign right here. And so the way that I teach this, the vertical value, the b squared, is always underneath the y squared, and the a squared, the horizontal value, is always underneath the x squared. So this is the generic form, y minus k squared over b squared minus x minus h squared over a squared is 1. This is what we're looking at right here. And so I guess I'll use marker as much as I can. So what this means is that the center of this hyperbola is hk, and so you got to be a little careful here because the y term is in front, but so when you go to write the coordinates, which is your x and y, this is going to be a -3 and then a +2. That's our center, and everything is based off of the center. Underneath the y is the b squared, so b is equal to 2. Underneath the x is the a squared, so a is equal to the square root of 16, which is 4. And so because the y is leading, our parabola is going to be drawn like that. The vertices will be on the y-axis, and so this will be where our vertices are. The foci will be in here somewhere. And so that's what I'm expecting my shape to look like. So everything is based off of the center. So you got to go to the center first, and so I'm going to go over here. -3 up to, and this point right here is the center of my hyperbola. It's not part of the graph itself, but it helps form the graph. Okay, and so in order to form the graph, you go left and right, a units. So I'm going to go to the right, 1, 2, 3, 4 units here, and put a point. And then I'm going to the left 4 units. So this is -1, -2, -3. -4, -5, -6, -7. 4 units will be right there. And then I go up B and down B. Down from, this is -3, 2 right here, so I'll write that in pencil. It gets kind of crowded sometimes, so I might have to erase that. But I'm going to go down 2 units, so that from this point I go down 1, down 2. Right here on the x-axis is where one of those points lies, and then I go up 2 units from there, and that is where this point lies. Okay, from those 4 points I form a little box. This is the box method, or the rectangle method. You form a rectangle off of these points that you went up and down off of. And then with these, what you do here is you can draw the asymptotes of the curve. You draw diagonals through this rectangle. This is a sketch, so it's not perfect, but it's going to be okay. What I've just drawn are the asymptotes for this curve. Now, I have the mistake of sometimes I might accidentally draw my hyperbola facing this way, but that would be incorrect because this equation came to me. The y term is the positive term. In this case, it's the one in front, and so this is the way, this tells me that my graph will be right here, and it's going to follow sort of these asymptotic curves, and like this. Okay, this is my sketch. That means at this point right here, this is a vertice, and this is a vertice. Those are on the graph. So on the side, I'm going to label the important points, V1, V2. So let's see, what are these coordinates? This is -3, 2, and so I went up 2 units, so this has got an x-coordinate still of -3. But I went up 2 units, so that's landed at -3, 4. Right here, I'm at -3, 2. I went down 2 units, and so this V2 is still got an x-coordinate of -3, but it's on the x-axis, it's at -3, 0. All right, the slopes of the asymptotes, let's go ahead and label those. The slope, m, of the asymptotes, that's these lines, the diagonals, it's always equal to, in general, it's equal to plus or minus b over a. So plus or minus rise over run. B is your rise motion, A is your run motion. So this is plus or minus b over a would be 2 over 4, which can be simplified to 1/2, up to right 4, up 1 over 2. You're going to land on these lines right there. So that's the slopes of my asymptotes. Lastly, I need to label the foci. I know they're going to land in here and here. The formula that goes with the foci for this, it's basically for a hyperbola, it's the Pythagorean theorem. It's c squared is a squared plus b squared. So in this case, c squared is going to be 16 plus 4, which is 20. So c is the square root of 20. That's what it is. And so this is a sketch. I don't have to worry about this too much, but square root of 20 is somewhere between 4 and 5. And so I'm going to go up from the center. Let's see. 1, 2, 3, 4, 5. Somewhere between 4 and 5, I'm going to put my foci. This will be F1. And then somewhere between 4 and 5, this is 4 point something. You could use your calculator to get a better estimate. I'm going to go down 4 units from the center. 1, 2, 3, 4, 5. This will be about right here. All right, so this is F2. Now, when I label my coordinates, I'm going to, oops, that's a 2. I'm going to be very careful. I'm going to label them accurately. The x coordinate for the foci is -3, both of them. How far up do we go? We go 2 plus c. So from the center, we're c units up to get to the foci. So since we were already at 2, F1 is going to be at 2 plus the square root of 20. And F1 is going to be at 2 plus the square root of 20. And F2 is going to be 2 minus the square root of 20. Now, you can simplify that radical square root of 20, but it's okay. I'm just going to leave it like that. And that's an accurate answer.